everybody. Welcome to OpenCV Weekly Webinar. I am Satya Malik, and today we are going to discuss OpenCV AI Competition 2022. And with us is Bradley Dillon from Luxonis, who will explain us the various components of OakD Pro and how it is related to this competition. And also with us is Phil Nelson, as always, who is the Director of Creative and Content at OpenCV. And if anything goes wrong in this webinar, it is Phil's fault.
That's right, Satya. It is me once again, the co-host with the co-most, the second banana who is second to none, your plus one and only. First of all, reminding you that we're coming to you from a slightly different setup here than normal. We normally have our awesome virtual set. The cat got into some wiring chasing a wireless mouse. It's the kind of thing that happens when you're doing these metaversal constructs. Anywho, a couple of things we do every week here on the webinar is take questions from you in the audience. Please use that little Zoom Q&A button to ask your question at any point in the webinar, or ask your question in the comments section of wherever you're watching the show, LinkedIn, YouTube, Twitch, Twitter, etc. We're also going to do a special giveaway to one lucky viewer in the Zoom audience. If you're not in Zoom, you can get there by going to opencv.live. Later on in the show, I'll be asking a trivia question based on the presentation, and the first person to answer it correctly will win the OpenCV course of their choosing. So please stay tuned for that. Back to you, Satya.
Yeah, so I see what you did there. When I said that if anything goes wrong, it is Phil's fault, you actually diverted it to the cat. You blamed the cat for the problems.
What are animals for if not blaming when things go wrong?
All right.
Yes.
So we will discuss the OpenCV AI Competition 2022 shortly. But before that, I think let's invite Bradley so that we can learn more about OakD Pro. And OakD Pro is the AI camera, the spatial AI camera that will be used in one of the tracks of the competition. And so welcome, Bradley.
Yeah, sounds great. Thanks for the introduction. And just to confirm on your side, Phil, are you seeing the screen okay?
Sure am. Looks good.
Perfect. Okay. Well, for those of you who don't know me, my name is Bradley Dillon. I work at Luxonis doing a few different things, kind of sales, operations, and then the finance side of things. And today I'm really excited to talk to you all about some of our products. So we'll be covering the OakD Pro, and we're really excited about this product. So originally, you may know Luxonis for the OakD that we did a Kickstarter on back in 2020. And then we did the OakD Lite Kickstarter back in 2021. And so those two products, the OakD and OakD Lite, we call those our Series 1 of products. Mm-hmm. And it was just really our initial models. And we always knew that when we did a next generation that we wanted to do two things. We wanted to improve on all of the things that customers hated about our first generation. And then the second thing we wanted to do is really unlock all kinds of new capabilities.
Which were obviously very few things were hated because it was essentially perfect.
If only product development works like that. I like it. So for the second generation of products that we have, some of the capabilities we're really excited about unlocking. One of them is being able to do nighttime operation. And then a second really popular one is being able to have the ability to have a wide field of view lens options. And so this version here that we'll cover today is our standard, but there is also the wide field of view that's available for it. One last thing I wanted to share about the OakD Pro that's cool about our second generation, and this is what I like to consider the tides of creative destruction, and also to hammer down that the original OakD was not perfect, is actually the OakD Pro is now the #1 selling product at Luxonis, even though we just launched it in June. So the customers are saying that we did a good job, at least with their wallets anyway. So the product that you see here, you can see on the right-hand side, the top and side view. So similar to some of Luxonis's standard products, you have the RGB camera in the center, and then you have the stereo pair that you see on the sides. It's no mistake that the stereo pair is about the distance between like two human eyes, which is originally where that concept came up from. So the things that this adds compared to the original OAK-D, two big things is you have the IR laser dot projector and then the IR illumination LED. And that's what really unlocks a lot of capabilities. The thing about the Luxonis OAK-D devices as well is that you're running all of the AI and CV functions on device. So there's 4 trillion operations a second. And actually 2.6 of those is dedicated to the CV functions, which is often a little bit underappreciated, but it's really ties everything together to make everything work. And then there's the 1.4 trillion operations a second for the AI functions. Going down to kind of the stereo depth perception that you see there. So that's able to run at 120 frames per second, whereas the RGB in the center is able to run at 60 frames per second. And so this standard model, the stereo pair is 1 megapixel, and then the RGB in the center is 12 megapixel. And this product, like something that we pride ourselves in, is incredibly lightweight, incredibly small form factor. So you can kind of see it's generally like this form factor that you see here. So it's incredibly small. You're able to do the video encoding that you see there, some of the obviously the classic CV functions, and then you can do things like object tracking, 2D and 3D. And then going on to some of the kind of specific functionality that's really unlocked. So on the left-hand side, that's the before and after you have the flood IR LED illuminating. So this makes it so that you can tackle applications that have low light or no light. So we have some examples where their customers are using this in a completely no light scenario, like inside of like a sealed container. So you can run all of your AI and CV processes on frames that are illuminated by the IR LED. And then on the right-hand side is you can see the difference in the depth performance for whether you have the active versus the passive stereo. And so the laser dot projector, we like to call it that, imagine like a little kid basically spray paints a wall with a bunch of dots. It gives it that texture. And so the example picture here is really one of the most difficult textures to be able to see depth accurately on. And this is not just a problem for our devices, it's a human problem, right? You ever had that feeling when you get up close to, say, a chain link fence or a wall that just doesn't have texture? It kind of causes that trippy thing where you kind of go, oh gosh, how close is that right now?
Your eyes don't know where to focus. Like it kind of tricks your mind.
Yeah,
exactly.
The visual you can have in your mind is that, let's say you have a completely smooth white wall, right? And you're standing very close to it so that your entire visual frame is, occupied by that wall. In that case, if the wall moves, you will get no sense of motion. You don't know the wall has moved. It is a completely smooth motion, right? So there is nothing that tells you that the wall has moved. But let's say you have a vertical line, half black and half white. So one side is white and the other side is black. In that case, if there is this kind of motion, the horizontal motion, you will be able to notice motion because that line moves. But if you move up and down, you will not be able to see any motion, right? And for you to see motion in both dimensions, you need to have a corner, right? And that is why the same thing happens with stereo algorithms also. They want to look at features which are stable, like corners, and then they can latch on to the same feature in 2 different cameras, and you can do the triangulation. But let's say there is only a line in 2 different cameras. You don't know which portion of this line corresponds to which portion of that line. So there is an ambiguity. And if it is completely textureless, then there is ambiguity in 2 dimensions. So that's what you see in passive stereo example here, that with white walls, there is nothing for the stereo algorithm to latch onto. But with active stereo, you're projecting IR light onto the scene. So even your, do you have by any chance the projected dots, a picture of the projected dots, Bradley?
The speckle pattern, as it's called occasionally.
Yeah, I maybe we could share it later in like the notes. I don't have it.
Sure. Okay, that's okay.
I don't have it
so what this dot projector does is literally projects dots onto the scene. It is almost like, the Christmas lights that are projected onto the wall, except that this is IR, so it's not visible to the human eye. But the cameras have IR filters removed on them, right? So these grayscale cameras that we have for stereo depth estimation, Usually all cameras have this IR filter because humans cannot perceive IR. We want to cut out that IR light. But in case of stereo depth estimation, we remove this IR filter from the camera so that it actually perceives IR. All sensors are capable of perceiving IR to some extent. We actually have to take extra steps to cut out that IR. And here we simply removed it. Now, these RGB camera, these grayscale cameras can actually look at these dots and do triangulation very accurately. And that is what you see on this active stereo. That is why the depth estimate is so solid. So solid blue means that it is estimating the wall to be all at the same depth. And there you see that it is unknown. It shows blue dots at some positions, but black means it cannot estimate the depth in most of the areas.
It's essentially like a NAN, basically. It just doesn't know. Yeah, so folks in the chat have brought up a couple of analogs here. Yeah, really similar to the original Microsoft Kinect, and also really similar to the way that Structure Sensor and Structure Core functioned from Occipital. So something that I'm very familiar with, having spent a lot of time with those products. Go ahead, Bradley.
Yeah, wonderful. So a couple more slides, just covering some of the kind of the hardware features. So for the lenses, we have options for autofocus and fixed focus. About 2/3 of the devices that we sell are autofocus. So that's the most popular. When we went to originally launch these, we thought it'd be more than 90% autofocus. So I was actually quite surprised at how popular the fixed focus has been. And so fixed focus really comes up as being a suitable option when you have high vibration. So example would be on if you're on a vehicle, say like farming equipment, drones, things like that. I'd say drones is actually the highest vibration environment we've had to deal with. And that's where fixed focus can really help a lot. And then you can see with the camera specifications there on the right. So the sensors for the center camera is the IMX378. And then the stereo pair is the OB9282. I mentioned before kind of the resolution and the frame rates, but just to share again, so the IMX378 is 12 megapixel, and then the stereo pair is 1 megapixel, and then they can run at up to 60 or 120 frames per second, depending on how heavy your model is that you're running.
So Bradley, one question I have for you. Typically, the way I think about fixed focus and autofocus is for applications where my camera is kind of static and it's not moving at all, then autofocus makes a lot of sense. Like if I'm using a webcam kind of situation, then it makes a lot of sense. And when things are moving, then maybe fixed focus is, even if it's not, a very high vibration environment like the drone, but let's say even if it is moving on a robot, right? It's on a robot. Do you think in those cases also fixed focus is the right choice?
Yeah, from what we've found is that if the Oak D Pro is on something that's moving, even if it's moving in a completely like linear plane, like it was on a track, that it does tend to be more popular for customers to go with fixed focus. It seems that they tend to try to experiment with autofocus and then end up saying, no, yeah, we actually do want to go with the fixed focus option.
Right, because autofocus will go out of focus sometimes, right? Just to try to adjust to this fast changing scene.
Yeah, exactly right, yeah. And then last slide I'll cover here, and this is just a little bit more unique with the Oak D Pro from some of our other devices, is that, so you have the USB-C, but if you're actually running the dot projector and illumination LED, you need a little bit more power to be able to do that. And so with the product, you get the Y adapter that you see here, and then you plug one line of it into the wall and the other line into your whatever your host is. So just want to share that detail. When you take a look at the product at Lexanis or in our shop, you see that as well, but I just want to highlight that.
So just to be clear, let's say you have turned off the dot projector, you have turned off all these things, and you're essentially using it as an OD, series 2. In that case, connecting it only to the computer will also work, right? Or are
That's
you
correct.
required? You're not required to put in the 5-volt external power source in case you're not using the dot projector and the floodlight, right?
Yeah, it's already for. Yeah, that's correct.
Okay.
So if you're just using it without those functions turned on, then you can use the USB-C and you just connect it right to your host, and then the host is able to provide enough power, and then also the connection also provides the data connection as well. So it's only if you have those functions turned on that you actually need the external additional power source.
All right. So okay, so that's about OAK-D Pro itself.
So
Now let's talk.
got a couple more questions about the
Yep.
OAK-D Pro before we move on here, since it's fresh in our minds. One question from the chat over on LinkedIn was about the power draw. When using with the dot projector on and with it off, what kind of power consumption can we expect? A lot of folks use this stuff with like a Raspberry Pi or a lower power, smaller microcontroller setup, and so they're interested in that stuff.
Yeah, absolutely. So we can share the data sheet that you see on our website to give more details over the actual kind of volt and amp breakdown for the different modes. But generally, if you're using it without having the dot projector illumination LED, the general operation I think is around 4 to 5 watts. And then let me actually pull our data sheet up live to make sure I don't miss.
Pulled it up. I just pulled it up here, so I'll look at. I just linked it in the chat, but I'll also try to grab the voltage here.
Yeah, I just wanted to make sure that I did misspeak and set people completely astray.
Yeah.
Of what it is there, but I believe it's. Well, yeah, I don't want to speak out of turn. One sec.
It says max power consumption 7.5 watts.
Yeah, that was gonna be my guess with those
minimum 4 watts, maximum 7.5 is the recommended operating conditions for those out there who wanted to know.
Yeah. Okay. Perfect. Thanks, Phil.
And yeah, no sweat. And we will add the data sheet to the show notes when this goes up on YouTube. Yeah, Satya, as you were saying.
Well, no. Let's go over the questions, and then we'll go over what is in the competition. What do you need to do with this camera in the competition, and some ideas. I'll throw out some ideas.
Yeah. So Aaron would like to know: is this a passive infrared filter? Is there any filtering going on with the infrared here?
Yeah, that's a great question. So there is a filter. Let's see here. So it has a notch IR filter at 940 nanometers.
Okay. Thank you. I see Eric from Lexanis is holding things down over on LinkedIn. Thanks, Eric. We've got some good questions over there, but he's taking care of them. Let me just take a quick look. So John would like to know what does OAK-D Pro do for situations where the infrared projector might be washed out, like if you're outside and you can't compete with the sun in terms of infrared. Nothing's going to put out more infrared than the sun. So how does OAK-D Pro handle that in those kind of situations?
Yeah, it's a great question. It's a tough challenge, right? In the outdoor environments like that. So I mean, from what I've seen is that customers just need to do a lot of different experimentation, changing some of the tuning that they can use for the device to be able to go optimal for their conditions. Obviously, it's difficult if you have an environment where you're wanting to operate it at nighttime and then the sun rises and you want it to keep operating perfectly. So I don't have a silver bullet answer there, other than to say that with Depth AI, the software that we provide, unlocks for you is the ability to change different parameters of the device. And if you also have any issues with changing those parameters and experimenting with it to get kind of optimal for your lighting conditions, you can also check with us in Discord and we can help you with what some of the different scripts that you can run to be able to make additional modifications.
Yeah. Can I qualify the answer with a few other things?
Please.
So first thing to remember is that somebody asked whether this is like Connect, and it is not quite like Connect, because in Connect 1, it was a projector camera system, which means that there was one camera and one projector which were calibrated, and then you did the triangulation. They were not two cameras, right? In this system, we have two cameras and a dot projector. So let's say you turn off the dot projector, or the dot projector is not useful, let's say outdoors. The stereo pair will still produce a reasonable depth estimate. It will not produce as good of a depth estimate when you have white walls, etc. But it will be perfectly fine in outdoor conditions when you're using, because it's using two cameras in that case. Even if the IR dot projected thing is gone, you still have the texture in the scene itself, which helps to generate the stereo estimate, right? So you still have the two cameras, and you will get reasonable depth estimates. They will not be as good as for smooth surfaces, right? Or single colored surfaces, but you'll still get a reasonable depth estimate. You can do a lot with that pure stereo or passive stereo depth estimate.
Yeah, it seems much more robust. There's a lot fewer ways where it will catastrophically fail versus a single camera system. Yeah, especially with the AI power in there, you can combine these kind of sensor inputs to get a much stronger map of depth.
Right.
I got a couple more questions about OAK-D here. Niraj would like to know, are there any examples of 3D tracking using OAK-D Pro currently out in the wild, Bradley? You're muted over there, by the way.
Yeah. So I don't have one that I can link right now, but we can put it in the show notes. That we do have some depth AI experiment examples of 3D object tracking that we can share afterwards.
Cool. Thanks for that. Ivan would like to know, can you get raw infrared images off of the device?
I have no idea. I wish I knew on that. Sorry.
Hey, it's no shame in not knowing.
Yeah, sorry about that.
No, so okay, I have not actually worked with OAK-D Pro myself, but you can, in OAK-D, for example, you can get the raw black and white images out, no problem, right? And I'm guessing that with the dot projector turned on, it's the same API, so you should be able to get the raw images out. But I want to make sure that it's not raw in the raw sense, right? It is not
raw formatted.
Right, like in RGB case, you don't get the bare pattern out, as far as I can remember. But it is raw in the sense that you can get the images out, and if you want to do the processing on your own machine, you can do it, right? So you get, let's say you want to develop a stereo algorithm, right? And you don't want the limitations of OAK-D Pro, because it's still, you want to use a humongous GPU to do it. You can still capture using the stereo pair, get just the images out, and do the processing later on. So I think, yes, you can get the images out of them.
I'd be very surprised if that weren't the case, knowing the way the Depth AI API has been built up. So yeah, it seems like a safe bet. Yeah. We'll get Keith Bowers would like to know, what's the pathway to replace, if you want to upgrade from, say, OAK-D to OAK-D Pro, are there any software changes that need to happen in order to make that work, or is it just sort of a drop-in replacement?
It is a drop-in replacement. So it's the same Depth AI software. So there shouldn't be any issues with going from one to the other.
Yeah, developers love hearing that.
Because I know what I know, Keith. I just want to add one more thing, that in case there is, in very lit environments where there is a lot of sunlight or things like that, or when there is, this thing is very, things are not close, they are very far away, then the benefit of using the laser dot projector is not as much because, you don't see the projected pattern. So that's something to be careful about, that let's say you are putting it in some situation where the objects are very far away, then the laser dot projector may not produce any better results.
That is a good segue into the next question, which is, what's the operational range, the recommended operational range for the infrared projector here?
An operational range, you mean the
sort of the recommended minimum and maximum distance that it'll get, decent depth.
Got it. Yeah, so Dr. Malik was correct that like for further away, it becomes less effective. I think that the example that we shared in that deck was like from about 5 meters that it was still performing well. But I think somewhere around that distance, further than that distance, where it would be you'd start to have an issue with how accurate it would be. And then obviously up to close steps, it's similar to the depth perception that it does work fine up close. But then if you get very close, like, inside of whatever it is, 20, 40 centimeters, then you would start to have an issue with your performance.
Okay. That makes sense to me. Any last call for questions on OAK-D during this part, or OAK-D Pro during this part of the webinar? Get those in there if you got any. And before we move on to talk about this exciting new competition, the fourth in our series. Aaron has a question about how autofocus is implemented on the OAK-D Pro. That might be a little bit too in the weeds to answer well here, but I just wanted to throw that out there. If you have a quick answer for that, Bradley. If not, we'll just have to put a pin in it for now.
Yeah, so it's a great question. The implementation for it with the Depth AI API is where you can make some adjustments there. But yeah, we'll follow up with more details after the show.
Excellent. Yeah, and I was using OAK-D as a webcam for quite a while, and I do remember you could sort of set the focus even with the autofocus version. So yeah, it's a interesting question there. So yes, let's shall we move on to talk about this amazing competition?
Well, so even before that, let's talk a little bit about a depth estimate, right?
Sure.
So traditionally, depth has been estimated using a stereo pair. You have two cameras, and if in both cameras you can locate one point, you can say that this point projects onto this, this camera at this location, and the same point in the other camera location. You can, if you can find the exact location of a 3D point in the two cameras, and if the cameras are calibrated, both intrinsics and extrinsics, which means that you know how the cameras are related to each other in space, and what are the intrinsic parameters of the camera, like the focal length. In that case, you can do triangulation and figure out what is this point in 3D, right? Now, so that's classical stereo. That is what we also call passive stereo here. And we have two images here. We have two cameras which are identical. So matching those points is relatively easy. Now, how can we improve upon this passive stereo? We added laser dot projector, right? So extra patterns are thrown into the scene so that matching becomes easy. And it's all about matching. Once you do the matching, it's going to work very well. Now, that's with two cameras, right? But OAK-D has 3 cameras. There is a central RGB camera also, and one can make a case that, because you can calibrate the entire 3-camera system, why not use the third camera also to get an even better estimate of the depth, right? So that is one way to improve the quality of depth estimate. And the third one is that this is a spatial AI camera, right? It has 1.4 trillion operations per second available for AI, which means that you can use a neural network to improve the depth estimates. So if you look at the literature, there are a lot of a lot of new algorithms that are coming up, which are using data to actually improve the depth estimate, right? So the traditional methods, they are based completely on geometry, right? You do this feature matching, and then it's pure geometry. You don't need a prior knowledge of the scene. You don't need anything. It is basically, there's no training involved in creating these stereo algorithms. But let's say you have knowledge of the scene, you have a lot of data from this camera in various conditions, then you can actually you can train a neural network to refine the quality of this estimate. And just to give you an example, right? Usually, but not always, let's say there is, let's say there is an object, there's a yellow ball in front of a white wall, right? Or let's say a red ball in front of a white wall. Now, because the ball is so smooth, you will not get very good estimates based on depth alone. But you know from your experience that this yellow ball, this red ball is most likely not painted on the wall, right? Especially if you can see the shadows, etc. In that case, the color is giving you information that they are at different depths, right? It may still be an illusion, but most likely this color, because the ball is a different color and it's producing some shadows, etc., there is some inference to be made that it is, it's a separate entity than the wall, even though the ball and the wall may be completely smooth by themselves, and the stereo depth, the classical stereo depth estimates may not be right. And the way to do it is that, if you close one of your eyes, people think that, humans make depth estimate because we have two eyes. That's only partially true. So you can close one of your eyes and you can still have a very good estimate of depth. How are we doing it, right? Part of the reason is that we have other cues for depth, like shading tells you a lot about depth, right? Or the shape also. You also do depth by focus, things that, the eye focuses to estimate the depth. And finally, colors and prior information, that's a cup, from prior knowledge of the world you have. So you can do a lot of depth estimate even with one eye, right? And that's the key thing that we are trying to leverage, that humans are able to estimate depth even with one eye pretty reliably. Not as good, right? Let's say a fast ball is coming at you. In that case, having two eyes is definitely better than having one eye. Actually, having two eyes is always better than having one eye.
Especially if the ball hits you in one of the eyes.
Right. but my point is that there are other cues than this triangulation that we do in traditional stereo that helps us estimate depth. And we are hoping that people will use all the capabilities, the 3 cameras in OAK-D Pro, as well as the computational power available, the ability to run neural networks on the device itself to refine the estimates of depth. And that's what the spatial AI competition is about. There are 2 tracks in the competition. The spatial AI part is all about improving the depth estimate of OAK-D Pro. You'll have to do better than what it already provides based on, you can use the 3rd camera, you can use neural networks, but ideally you would use all the capabilities of this device to create a very refined depth estimate. And then we have divided this piece into the problem into 2 parts. One is that if you're above 15 frames a second, we will judge you only on the quality of your depth estimate. So there is no benefit of running, suppose you could run this at 30 frames a second, but at 16 frames a second, you could improve the quality a lot, then run it at 16 frames a second, right? Use that extra time. That's the competition. The second one is that if you are below 15 frames a second, in that case, we will penalize you, because then it doesn't feel like real time. We will penalize you, and you will have to be a lot better in quality to actually win the competition. So that's one little caveat.
Yes. So, OpenCV AI Competition 2022. Officially open for submissions as of last week. We've already gotten quite a few from folks on one of the tracks, more than the others so far, because one's a little more wide open than the others. The first we will talk about here, first I'd like to say thank you to our co-sponsors, or our co-organizers on this competition. We've got Orbic, Katas, and Luxanis, and OpenCV China helping us out here. Big thanks to OpenCV China for actually localizing the competition pages in Chinese for the first time ever, which is awesome.
It's also actually the core OpenCV competition. They are taking a lead. OpenCV China is taking a lead. And part of this came from the fact that in our last competitions, we were seeing very little participation from China. And OpenCV China folks said that this is because of the language barrier, and also, the way we share things. For example, Google Drive may not be accessible and things like that.
Yes,
it was becoming a problem. And so they took a lead on this one. And, for people who are from China, they can easily compete. They produced all the they are also judging, but they also produce the Chinese version of the page.
And yeah, thanks so
and
much.
And ArduCam, I believe, produced the Chinese version of the spatial AI track, our friends at ArduCam.
Yeah, as we said here, there's 2 tracks to this competition. We like to do something a little bit different every time we do one of these. Last time we focused on Legos, and that was a lot of fun. This time we are focusing, we're going with 2 tracks. We've never really done a sort of split focus competition like this, and I think it's always good to experiment. So as we've been talking about, the first track is, one of the tracks is Core OpenCV. We'll talk about that in a moment. But another track is the Spatial AI track. As Satya just discussed, we'll be giving out prizes for folks who submitted a proposal to improve the depth quality with OakD Pro. And so you can see, we saw some glamour shots of OakD Pro already, thanks to Bradley. But we've got on the webpage here a few more, and also some of the specs are reproduced on this page as well. But importantly, it is fully localized in Chinese. So if your English is not so good, or you don't speak English at all, I don't know how you're understanding what I'm saying, but you can read it in Chinese. The introduction here, if you need a little bit of a refresher from what Satya just discussed, you can find a lot of that information on this page, as well as some really great pics of the system and the split power adapter that we talked about earlier as well. But the important parts here are the dates for submitting your proposals and the dates when those proposals will be selected down. So proposals opened up last week on the 22nd. They are preliminary proposals are due by September 15th, 2022 at 11:59 p.m. Pacific time, UTC -8 for those of you who are sticklers for that sort of thing. There is a JOT form application for you to fill out and upload the PDF of your proposal. With this track, we will be then down selecting from all proposals for 25 teams who will be selected to compete in the finals, and they will have until December 18th to submit their final projects after being chosen. So the cool thing about being chosen here is you will get an OakD Pro absolutely free in order to work on this project. I think Satya did a good job of describing the parameters that we'll be judging this on. Is there anything you wanted to add, Satya, for this track in terms of what we're looking for both proposals and for the final projects?
Well, so the most important thing is showing expertise, right? That if you have, when you do this proposal, because there is nothing else, right? This is not unlike previous competitions where we said that what is your idea? So there was an originality of idea that also counted. Here we have described the problem for you. We know exactly what we want to do. So the proposal, the choice, the teams that we will choose will depend on uh, how thorough they have been in uh, knowing the literature, right? You should go and look at all the literature. You should look at all the various pieces and tell us roughly what are you going to try, right? So you could cite papers. So all those things, you have to convince us that your team will be able to pull off this thing. And for that, basically read extensively. You still have more than 15 days. So read extensively what's out there in the literature, what is the latest in neural depth inference, and also classical stereo, how you can improve. So put together a proposal which is technically solid, right? And that's why, unlike last time, right, we used to give hundreds of these in prizes, right? The first round used to be hundreds of people. Here we think that you need some technical depth to be able to compete. So please show that technical depth so that we can send you the OGD Pro and you can go to the next round for the implementation part.
Yeah, we talk about this a lot on the show, that it's sometimes easy to overestimate the difference between yourself and people at the same level as you. A lot of the time, if you're at we're looking for these top experts in the field here, and a lot of the time the difference is just minute, so small. You see it in sports, especially the very top athletes beat each other by fractions of a second all the time. Or in baseball, it's the single that wins the game, and that's important to pay attention to here as well. Presentation matters, and the way you describe yourselves and tell how you're going to solve this problem really matters for these preliminary submissions.
Right. And I think a strong team is one which can put together things, right? We are not asking you to come up with something. It's a very short competition, right? In 3 months, you're not going to come up with a novel algorithm. So if you have an engineering team which can look at all these solutions and pick the right ones which will help improve the depth estimate, that is the kind of team which is most likely to, pass the first round and win the competition. People who, you don't even need deep technical knowledge about the specific things, but you need to be able to put things together and have a knack for understanding that, oh, this neural network will work on this device. And you can see some, based on what you have read, you can see some examples that, oh, this is the right kind of network, or this is the right kind of strategy for attacking this problem, right? So it's a more engineering focus than a research focused competition, in my opinion.
Makes a lot of sense. Anything to add for this part, Bradley? Not really?
No, nothing from my side.
Cool. So the most important part of this, of course, is the prizes.
Can I add one more thing that I completely missed?
Go ahead, Satya.
So I don't know exactly how you would use it, but there is also an IMU with the OGD device, right?
That's correct.
So if you want to use that information, that can also improve the quality of your estimate, because you get motion information, the motion of the camera also, in case the camera is moving.
Yeah, you've got a smorgasbord of sensor data here you can use to improve the depth. Absolutely. So the most important thing here is, of course, the prizes. As we said, the deadline will be December 15 for people to submit their final projects for the 25 teams that are chosen. You have until September 15 to submit your proposals. That's 15 days from now. Please get those in. The final teams will win $5,000 for first place, $3,000 for second place, and $2,000 cash for third place. But participating in this is its own reward. I think people find this often in the contests, that giving yourself a goal, giving yourself something to work toward, even if it's sort of arbitrary like this contest, you can surprise yourself, and it's always good to try things that you're not sure you can do as well. So don't be scared to apply. We're not going to put you on blast and tweet about how bad your application was. Give it a shot.
Right.
Like I said, you can also find the specs here on this page. So if you've got any other questions that you need some more detail on, you can find those specs on the Spatial AI track page as well. Satya?
I also wanted to add that the people, let's say you submit a proposal and you're not in the top 25. And if you decide to, it only means that you will not be given an OAK-D Pro for free. But let's say if you are motivated, you think that your idea was solid and we made a mistake and did not select you, you still have the option of getting an OAK-D Pro yourself and directly submitting for the finals. We don't mention it on the site just because it feels like we are trying to sell OAK-D Pros.
Right,
we are not. That's not the goal. I just want to make sure that people understand that's also an option in case you're not in the top 25. But it's not, I didn't want to say it on the website because it feels like we are trying to sell the OAK-D Pro.
Yeah, that's understandable. Yeah, so like Satya said, to summarize, if you're not chosen as one of the 25 teams, and you can prove us wrong, buy an OAK-D Pro and do a better improvement, and you can still win. Yeah, so that's the main stuff with the Spatial AI track of OpenCV AI Competition 2022. You can follow the progress of teams, and we encourage folks to post their candidacy and whatnot on their social media platforms using the OAK22 hashtag. So we're going to now take a look at the second head of this competition, which is the core OpenCV track. This is the one I'm most excited about because it's similar to our previous competitions. It's pretty wide open in terms of what people want to work on and create and improve. Unlike previous ones, like I said, we like to try new things. There's actually multiple kinds of prizes on this track, and you can use different flavors of hardware to build your project, and you can also win up to 3 times on this track for the same project. Thanks again to our sponsors, OpenCV, or our organizers, OpenCV China, Orbeck, and Caras. We have some suggestions for areas that you might want to focus on that seem interesting or have done well in the past, or just that are going to be cool to see. Those are robotics, agriculture, education, visual assistive devices for folks with vision problems, health and medical, and I love it says miscellaneous as suggested areas. I don't know. I don't know how you suggest miscellaneous, but I like it. It's got Moxie. Importantly here, there are 3 tiers of prizes. There's 3 different kinds of prizes you can win. Cash-wise, the outstanding winners, the top 3 grand prize winners for this track, first prize will get $5,000, second prize will get $3,000, and third prize is $2,000 cash. Everybody that the top 10% of teams will get a special certificate identifying you as a top 10%er in this contest, which you can then share on your social media platforms, put it on your resume. It makes you look good. Trust us. We'll have some guests coming up later on the webinar in some future episodes that will tell you just how much participating in these OpenCV competitions have helped their careers. So look forward to that. The other ways you can win here, cash-wise, are using an Orbeck 3D camera. You can win first prize $750, second prize of $440, and the third prize of $290. And you can also, if you use some of the Caras hardware, you can win $1,480 for first place, $740 for second place, and third place teams will win some gear and also a certificate. You can technically win first place in all 3 of these. if you are clever with your project and the way the certain hardware that you use. I really hope some team tries to do this, but
I want to
maybe that's
emphasize
just
that
me.
it's not required to use any hardware at all. It could be a
Yeah.
pure software also. Um, it is just that our sponsors, they said that if you use special hardware, their hardware, in that case, there are additional prizes. But
Yeah.
to participate in this competition, you don't actually need a hardware solution. It could be pure software. Also, it should use OpenCV, but other than
Mhm.
that, it can be a pure software solution.
Yeah, that's the only thing that matters here is that you're using OpenCV as a core part of the problem that you're solving. And we're always trying to get you guys more money. So thanks again to our co-organizers for having the great idea to give you more money, more ways to win money. So the timeline for this aspect of the competition is a little more, and the submission process is a little more loose than the spatial AI track. For this one, we started the submission process, became open last week on August 22nd. All you have to do to apply for this one is send an email to competition@opencv.org. We'll make sure that email address gets linked in the chat here and also in the show notes. Describe the problem that you're going to solve, describe your team, give your team a cool name, and attach a PDF of your proposal, as in previous OpenCV competitions. We also have a sample PDF linked on the page if you're not sure what to say or what that should look like. The registration deadline is October 31st, 2022 at 11:59 p.m. Pacific time. Hopefully nobody gets waylaid by any ghosts or ghouls, as that is also Halloween. The final submission deadline is December 18th, 2022 at the same time. Again, to submit, you'll send us an email. We may have a form to help wrangle these final submissions a little bit better, but it'll probably also be over email. And there's really no approval process. It's important to keep in mind for this part of the contest, or the competition. Just tell us what you're going to do and then start doing it. Just go do it. So we're really looking forward to your out there ideas and also your very simple but well executed projects as well. There are full rules here. As with all of the competition, this is fully localized in Chinese, and if you want to send your submission in all Chinese and no English, you can absolutely do that. Teams are up to 1 to 4 people. Are there any geographic restrictions here, Satya?
Not really. I mean, there are some countries we cannot send, cash prizes to, prohibited by the U.S. government. But other
Right.
than that, there are no restrictions.
Yeah.
Especially because we are not even sending hardware in this case.
Mm-hmm.
So the restrictions are basically all the prohibitions by the U.S. government. Those are the only things we have to follow.
And importantly, if you're thinking about applying or letting us know what you're working on, the final submissions that we will be expecting from you will consist of working code and a strong video submission that demonstrates what you've done, as well as giving us some technical detail as to what you've done in the video. The video is 20%. The code is 80% of the grade there. We've got some do's and don'ts. Most importantly, we try to be ethical, behave ethically. Let's not. AI has a very serious ethics problem as it is. Let's not make it worse. It's easy to know if you're doing something wrong because you will not want to do it instinctively. So please be ethical with your submissions. We can't really stop you from doing stuff. OpenCV is an open source library, but come on, just try not to make me look bad here, folks. Any last thoughts on OpenCV AI Competition, OpenCV core track, Satya?
Well, OpenCV AI Competition. So the spatial AI competition, it does require some level of expertise that you need. For this one, there is no baseline, right? Because you can be very creative in the choice of your problem that you choose, and you can beat experts because they did not choose an interesting problem. So because
Yeah.
you define the problem yourself, it is much more easy for people who are even starting out to do a wonderful, presentation. So I highly recommend that if you are a little bit intimidated by the spatial AI competition, you should definitely participate in this, especially for, a lot of students come
Mm-hmm.
to me and ask, oh, give me a chance for working with you and things like that. And I have to politely decline, saying that, uh, you know, nobody gives you a chance, right? You prove yourself first, and then you are invited, right? People don't take a chance on you because you just asked for it, right? So the best way,
Except for nepotism, of course.
right? Now, the best way to shine in this, very crowded competitive world is to participate in some of these competitions. And let's say you're not from a very good school, but you're winning some of these competitions. It puts your resume looks good.
Mm-hmm.
It makes you stand out that you have done something important. And it's also what I would call a smart cut, right? That uh, somebody could have worked for 3 4 years and on their grades, etc., but somebody could have and that's great. I mean, they have an edge over somebody who has not. But then some of these things come up where you work solidly nights and weekends for 3 4 months, and you are able to be on the top of the competition.
Mm-hmm.
It's funny, you may actually get the same benefit
It's
as
true.
somebody who has worked for a longer period of time. So uh, these are kinds of these switches. These are these nonlinear uh, chances of changing your career in a nonlinear way. So grab onto it and see where it goes. And there are a lot of people who do it for a hobby, and I invite
Mm-hmm.
them also to, try their best. A lot of people, I was surprised when we did these competitions. There were so many submissions of people who were above the age of 50. I was
Mm.
shocked, right?
Yeah.
And in the very first competition we had organized, it was uh, somebody who was in their mid 60s or
Mm-hmm.
maybe early 60s. And it was such a great, I was shocked that they were programming and they were,
Well, yeah, you don't expect, since it's such, it's relatively new tech that we work with here. You don't.
yeah,
It tends to be a younger field. There's a lot of
it tends
lot of
to be young.
students, a lot of
You'd be
younger folks.
surprised, though. You'd be surprised that people who pursue this as a hobby, right? And they are even if their job doesn't actually require AI, they do it on the side. It's a hobby for them, and they spend a lot of time building
Mm-hmm.
interesting applications, etc. So to all of those hobbyists, also, I invite you, and I hope that you will come up with some very interesting ideas and great submissions.
Yeah, same here. And you can find a bunch of the previous winners on OpenCV.org of these earlier competitions. If you need some inspiration, I'll quickly just go over some of the. So our first one was in 2020. Satya, you remember this one well. I do as well. We got enough submissions that we doubled the prizes. It was originally supposed to just be 1, 2, and 3, but we couldn't decide. And so we ended up giving away extra that time. Our winner was this really cool backpack created by Jagadish Mahendran, who we gotta have on the show again, I think, one of these times. He was on an earlier episode of the webinar, but we should talk to him again. The second, let me quickly, I'll scrub through here and try to. Yeah, we're not going to have any audio here, but you can kind of see a little bit of this project that won the first OpenCV Spatial AI Competition, which was sponsored by Intel. The other first prize winner here was Universal Hand Control by Pierre Mangio. And I'll turn the volume down here and just kind of show you. So this was a very solid. These were both sort of surprise entrants to us. They weren't posting much on social media about what they were working on. And so when they submitted, we were all like, oh, wow, holy crap. So that was the first one. The second one was OpenCV AI Competition 2021, sponsored by Microsoft Azure and Intel. This one had a lot of stuff going on. Our grand prize winner was Team Cortic Tigers, who you've seen their CEO Yelu here multiple times on the webinar. Always enjoy having you here. Team Coletta, which created this incredible system, which is actually being used in hospitals to monitor neonatal patients, preterm neonatal babies that are born early, essentially. And Cerebros with this awesome next generation wheelchair that did obstacle avoidance and fore and aft, where a lot of these things fail. All very impressive projects. Please give them a look on the website and watch their videos as well. And the most recent one was OpenCV Spatial AI Contest, sponsored by Intel and Microsoft Azure. Again, our winner was Team ICANN Reborn, who you will remember from a previous webinar as well, who created this really cool 3D capture and sort of teleportation system with neural radiance fields. Very cool. Team UCA Robotics, which had this very interesting human-robot collaboration system where you could have authorized users of certain things. If it didn't recognize your face, then you couldn't use this item. If an item is in an area that it's not supposed to be, then you can't use this item. If you are moving past a machine that is dangerous to you, it would slow down the machine, things like this. Very, very cool human-robot interaction safety and collaboration tools. And of course, my personal favorite, Team Potato Lovers with the Colorado Beetle Buster, which is a little robot that finds and identifies Colorado beetles which love to eat potatoes before they're potato plants, and then just squirts them with a little squirt of pesticide, hopefully using way less pesticide overall, and having less of that leak into the ground soil and all that kind of stuff. Big fans of potatoes here on the webinar. I'm going to go ahead and stop sharing my screen here.
So I have one more comment about, so Patrick Ryan says that he's 58 and still actively codes. That's really good. And just to, I mean, even though I'm surprised by people coding till, beyond 60s, but it is not very uncommon for very successful people. For example, Gary Bradsky, who is the founder of OpenCV, he still codes, right? And when I first met him, it was a surprise to me, when he said that, oh, I'm setting up this thing. I thought that he's getting somebody else to set things up.
Isn't that what interns are for?
No, but he codes himself. Jeffrey Hinton, who is the godfather of deep learning, he says that you cannot, if you don't code yourself, then you cannot make progress, because you will always have second thoughts about the implementation of whoever you told to implement, and you have to try out new ideas yourself. So I'm almost 100% sure that Jeffrey Hinton also codes even now, right? So that's so it's a superpower, right? It is, but surprisingly, a lot of people, they just become managers and stop coding. And I think that's a loss. Very good programmers end up being managers and never code. And that's a huge loss for everybody.
Yeah, I absolutely agree. I think there's, well, there's, that's sort of slowly changing, and a lot of managers who don't really do anything all day are real scared about it. The remote work revolution, I think, has shifted the balance maybe to be a little more toward equilibrium, and a lot of people are really frightened. Mostly it's people that don't do any work anyway. So if you can tell, I've had some bad middle managers. Luckily, that's not a problem for me now. We've got a bunch of questions here. One of the things that I think is really important to mention for the OpenCV track of this competition, a lot of people use these as their first projects in OpenCV even. And we've had him on the show a few times, and I think it's a great way to give yourself a goal when starting with something new. Is a great way to learn not just that thing, but to also kind of force yourself to accomplish something. And so if you're on the fence, send in your proposal. The worst thing that could happen is you don't get chosen, but the upside is basically unlimited. So this is Phil saying you can do it. Bradley, do you have any thoughts on the either track of this competition? We're about 10 past the hour here. I'd love to hear what you have. Any encouragement for our audience out here?
Yeah, I mean, the thing I'll say is that like this is the coolest part of what we do. Like when we develop products like the OpenCV Pro, they're kind of worthless when they do something like this, like sit on a desk. And what we really love is being able to solve all these real world problems. And Alexanis is something that we tackle, some with some of our end users, where we like to see like what's a really hard problem that we can like actually solve, and then we know if we can pioneer that, then all of a sudden the way tech history works is then 1,000 people can go and solve that problem. And so it's just really exciting to see these competitions where people are able to come up with pioneering things, and just in such a scrappy way too, right? Like it doesn't require this isn't like some like big R&D investment from some big company spending millions of dollars. Like you can do like meaningful real world application development just quickly and low cost. So we love being able to unlock that, and we're really excited to see what comes out of the competitors.
Yep, absolutely. Could not agree more. And as a reminder, the registration deadline for OpenCV Core it's a little looser, but let us know what you're working on by October 31st if you can. For the spatial AI track, the submission deadline is September 15. That is in just over 2 weeks from today. So get those submissions in.
We didn't do the.
What's that?
We didn't do the question today.
Oh wow, we didn't do a giveaway yet. Man,
yeah,
he's still
please.
here. All right, we're gonna reward all of you good people that stuck with us today. Yeah, so this competition. For those of you who need a reminder or have never joined us before, we do a giveaway here every single week. I ask a question that I make up based on the presentation of the day, and one lucky viewer in the Zoom chat, if you're not in Zoom, you can get there by going to opencv.live, will win a prize. This week, the prize is the OpenCV course of your choosing. So get ready to answer today's question in the Zoom chat. If you have won in the last 2 months, please don't answer and give other people a chance to win. Some of you are just too quick on the draw and maybe too physically close. It's hard to tell if that actually matters or not. So this competition, like every other competition we've run so far, is tied intrinsically with the OpenCV AI Kit hardware line. The first 2 of these devices were part of a Kickstarter campaign. What were the model numbers of those devices? Y'all got short memories out here. You're almost there.
Actually, we got one.
Not both of them.
Yes.
Think of the first Kickstarter campaign, first one.
Oh, the very first one. Okay.
Yep. All right, so we've got. I'm gonna say Frank here was. I believe he was correct in what he meant to say, but was a little bit extra. I'm gonna give it to him. The answer was Oak 1 and Oak D.
That's
Oak
right.
1 and Oak D. So congratulations, Frank Bettinger. Please send one email to phil@opencv.org, and we'll make sure that you get the course of your choosing. You can see what courses are available by going to opencv.org/courses. Just let me know which one you want, and we'll make sure the courses team unlocks it for you. Satya, do you want to take us home?
Yeah, thank you so much for joining us. And thanks, Bradley, for giving an overview of OpenCV Pro. And as always, thanks, Phil, for organizing this, even with the hiccups.
Yes, this was one of those shows that, hey, the show must go on. The show must always go on. Thank you all so much for joining us in the audience there. We couldn't do this and wouldn't do this without you, because it would just be me and Satya talking to each other. Please have a great week wherever you may be out there, and join us next week, Thursday at 9 a.m., same bat time, same bat channel, where our guest will be our friends at Super Annotate to talk about bias in data sets.
That's great. Thank you.
Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by OpenCV Courses. Learn computer vision and AI from the best at opencv.org/courses. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.